In this video, I'd like to go over how to work a trig identity, but also how to submit your answer in ConnectMath. The thing about trig identities is that there's so many different formulas associated with trig functions, and that's because they're so related. That what happens is that you can have a lot of things that look really different, but they're actually the same thing. And that's kind of the point of trig identities, is to show how that can happen. So here we want to show how the left side, the expression, is the same thing as the right side. So when you are verifying trig identities, one method is to just pick one side and try to simplify that to get it to look just like the other side. And usually you do that by picking the side that looks the most complicated. So for a problem like this, I'd start with the left side. There's different techniques we can use. So there's trig techniques, which is, things like the Pythagorean identity, reciprocal identities, quotient identities. And then there's also algebraic techniques that we can use, like multiplying, getting common denominators, factoring. And then the one that I think, more easily forget about is actually multiplying by the conjugate. And that's what I'm going to do in this particular one. So I'm going to rewrite it first. Sine of theta over cosecant theta minus cotangent theta. So multiplying by the conjugate is when I notice that I have something more complicated in the denominator, like there's two separate terms, and it's usually easier if that's the case in the numerator, because then you can split it up into be separate fractions, but you can't do that when there's more than one term in the denominator. So one thing that we can do is multiply by a conjugate. And that's not even what you have to do in this problem. In general, with identities, there's lots of different ways to show the identity. There's not just one way. So if I multiply here, I get sine of theta times cosecant theta plus cotangent theta, all over cosecant theta minus cotangent theta, and I'm going to show how, why I would do this. And now I'm actually going to try, and before I do anything else, I'm going to type it into ConnectMath. I will say that where most people have trouble plugging into ConnectMath is they'll put more than one step in at a time, and then it doesn't like that, and it won't validate. So I'm going to go to ConnectMath now, and I'm going to type that in. So once you type in the new expression that you've written, you also need to select the rule. So what I used here was multiplying by the conjugate, which is not a trigonometric identity. It was just an algebraic technique. So I would select algebra. Okay, so it's saying that the expression that I wrote is the same as the first one, and it's also saying that it follows, the rules of algebra. That's what I've done, and that's all that I've done in that problem. Okay, and I might actually, the next step would be to do some multiplication. So here I'm going to go ahead and distribute the sine through, and that leaves sine theta cosecant theta plus sine theta cotangent theta, all over, and the bottom you could FOIL out. And here the reason why we multiply by the conjugate, why that's a technique, is the first ones, if I multiply that, that'll just be cosecant squared of theta because we have two of them. But if you look at the outside, that would be cosecant times cotangent. The inside is cosecant times cotangent, but negative. So those, when you add them together, cancel out. And so there is no middle term. And then if we multiply the last two, cotangent times cotangent is going to be minus cotangent squared of theta. So again, what we were doing was just multiplication, so that was just algebra, and I'm going to go ahead and type that into ConnectMath. I get that the typing in can be a little tedious, which is why there's only 3 problems like this on the homework. But I do think it's really good practice at showing all of your steps. So that was algebra again, and so then you click validate. All right, this means that it's all good and you can just keep going. If you typed in something that was not correct, either your expression was wrong or your rule was wrong, if either one of those is wrong, if you try to validate, it'll tell you no, and you can't go any further. So then you just have to retry. But it might be that your expression is correct, but not your rule. So make sure to go back and look at the rule too, to see if that's the problem. Okay, what do I want to do at this point? You know, the squares on the bottom definitely make me think of the Pythagorean identity. So I'm going to look into using the Pythagorean identity in the denominator. Okay, so I admit myself, I only have one of the Pythagorean identities memorized. That's because I don't like memorizing stuff. So the one that I have memorized is that sine squared plus cosine squared is equal to 1. Then if I want to figure out any of the other identities, I actually just use division to come up with the other identity. So in this case, I can either divide everything by sine squared or everything by cosine squared. And I look here, and if I wanted to get a cosecant or a cotangent, because if you multiply everything here by sine squared, and we can do that because I'm basically, dividing the left by the same thing I'm dividing on the right, which means I'm keeping the equation balanced. So if I divide everything by sine squared, sorry if I said multiply earlier, sine squared over sine squared is 1, plus cosine over sine is cotangent, so that means cosine squared over sine squared is cotangent squared. And then 1 divided by sine is cosecant, so 1 divided by sine squared is cosecant squared. All right, so here is another Pythagorean identity. And so then I can kind of see we've got a similarity going on here. So I can get it to look the same if I subtract cotangent squared on both sides. So that means if I just rewrite this identity, 1 is equal to cosecant squared of x minus cotangent squared of x. And that means I can rewrite that whole denominator as a 1. So let me go ahead and do that. And I don't think I have to write it as just over 1, so I'm actually just going to simplify that, although it might get mad at me. So let's just see. Let's see if I write that without the denominator at all. Okay, and I'll try to type that in. And the rule that we use is the Pythagorean. Okay, so it worked. And now we can move on and keep simplifying. So here's where another technique I think that's really helpful with identities is trying to convert everything in terms of sine and cosine. So the sine, we could leave that alone. The cosecant is the same thing as 1 over sine of theta. Here we've got another sine of theta. And here, if we wrote it as a reciprocal, it would be 1 over tangent, but that's not really helpful. We could instead write it as cosine over sine. So here is something I want to show you that I'll maybe see a lot in these types of problems. So I'm going to just write it like this. Sine of theta, and then 1 over sine of theta plus sine of theta, and then the cosine over sine. So here's the thing, and then you might go and select the rule. You might say, okay, we were using reciprocals, so validate. Okay, here's the thing, is it's saying the line is incorrect, which it is. The expression we have on the left is correct. The reason it's saying it's wrong is it's not matching up with the rule. And the thing is that we used actually 2 different rules here. The 1 over sine, rewriting cosecant as 1 over sine, is a reciprocal rule. But rewriting cotangent as cosine over sine is a quotient rule. So we need to actually split those up. And I think, I'll just save that. And I'll rewrite that as cotangent of theta. So not doing anything with that. So then what we have used is the reciprocal rule. It validates and it works. So let me just now rewrite what we had. So I'm going to leave the 1 over sine theta alone. We don't have to say we're using the reciprocal rule because it's already been done. But now we're going to say we're using a quotient rule. And it works. At this point now we can use a lot of algebra to simplify. And so let me go back to writing things down. If we have sine of theta, we could write that as over 1 times 1 over sine theta plus sine theta over 1 times cosine theta over sine theta, is that we do have some cancellations here. So sine over sine cancels, so that first one's a 1 plus, and then we have another sine over sine cancel. So that's cosine of theta. And at this point, I mean, with identities, there's so many different things that you could rewrite the expression to be. You always want to make sure that you're getting to what was actually stated in the problem. And that is where we were getting at. So that means, okay, we've gotten to our final answer. The thing, even though there's a lot of steps for trig identities, the nice thing is you know what the final answer is going to be. It's just a matter of getting there. So in this case, we got to 1 plus cosine of theta. So I'm going to write that in. And the rule that we use, we were just simplifying canceling, so that would be algebra. And validate. And once you get to that final part, in this case the 1 plus cosine theta, it marks it as complete.